Hey everyone, welcome to our next video. Going over to our notes. This one is going to be 1.2. I'll go ahead and write the title for us. So 1.2 is radian measure, arc length, and area of sector. I also wanted to mention, I'm hoping that the audio is a little bit better on this video. I noticed on the first one that I made, I didn't use like a headset or a microphone or anything, so I found it had a lot of feedback. So I'm really hoping that this one sounds a lot better for you. But I'll go ahead and get started. So first, talking about radian measure in general, I'll go ahead and write our definition. So the radian measure of an angle alpha in standard position is the directed length of the intercepted arc on the unit circle. This is what I would call a mathy definition. There's also a bunch of stuff in here that we have not really defined yet. So standard position is really just meaning where we have our initial side on the x-axis. So how we described angles in the previous section. Directed length just means a length that has some direction with it as well. So for instance, if my angle is all the way, obviously this is the initial side, and it's all the way over here, so I have some directed length of the intercepted arc. What does that mean? And also on the unit circle. So let's go ahead and draw what's happening here. So first, we're going to go ahead and start off with a circle. I'm just going to go ahead and draw a normal circle. And I want us to remember that this is 0 degrees, this is 90 degrees, this is 180 degrees, 270 degrees, and we do wrap back around to 360 degrees. What the intercepted arc on the unit circle, all of that, what it's really saying is if I have an angle, say here, the radian measure is the length of this arc right here, all the way up until that point. So this length is really what radians will measure. But of course we want to talk about how do we even figure that out, like how do we get that value. I didn't mean to erase that. I'll go ahead and leave it. So if we think about circumference, so if you remember, the circumference of a circle. The circumference of a circle is 2 pi r. If we're dealing with a unit circle, then our radius is 1. So the unit circle is a circle with radius 1. So if I plug that into my circumference, so I then have 2 pi times 1, which is equal to 2 pi. What this is telling us is that on a circle with a radius of 1 on a unit circle, and we do talk about the unit circle a lot in trigonometry, it says that the length all the way around the circle, the circumference, would equal 2 pi. So this is pretty good for us. This tells us that if we start here at 0, so we have no length, and we wrap all the way around, we'll end up at 2 pi. This actually leaves us with a conversion factor. That basically says that 360 degrees is equal to 2 pi radians. I don't want you to get too hung up on, having to see it as a full arc length and stuff like that. Like, I don't want you to get too caught up on that kind of wording. It really is just length, but it's determining how long, like where the angle is, just the same as degrees does, but really it's just another unit, and it does speak about it a little differently. In general, whenever we talk about degrees, it's a little bit more for understanding. I think degrees is a little bit easier to understand, truthfully, but radians is used more for calculation. So anytime we want to use radians in an actual like calculation of something, like we want to use an angle in a calculation, we're going to have to use radians to do that. So hopefully that makes sense. It comes up a lot with like formulas and stuff like that. You're probably going to have to use radians to do them. And we'll see some in this section that we have to be in radians. I also want to show you that this conversion factor can simplify a little bit. I could say, if I divide both of these by 2, I can say that 180 degrees is equal to pi radians. So that means that this is pi over here. And then let's go ahead and figure out the other ones together. So if this is 0 over here, and then this is pi, what do we think up here is? So it's really just half of pi, so we would say pi over 2. There's also a way that we could actually like use a conversion and stuff, and I'll show you how to do that in a moment as well. 270 would be 3 pi over 2. I'll show you another way to kind of figure this out. So if this is 0 over here, if this is pi over 2 up here, not necessarily a point, I'm just kind of drawing that dot to point your direction somewhere. I can write pi as 2 pi over 2. So now I see this denominator of 2. So I'm basically counting 1, 2, 3, and then 2 pi can be written as 4 pi over 2. This technique of like changing the denominators is something that you'll see me do a bit later, like I think I started that in 1.4, where I'll use it to help us figure out like where angles are while we're looking at radians. Let's talk about how to convert from degrees to radians and also vice versa. So example 1, I'll say convert the following angles from degrees to radians. And vice versa. So we'll do some from degrees to radians, and we'll also do some from radians to degrees. Starting off with part A, let's look at 270 degrees. Part B, I'll do a negative angle. Let's do negative 210 degrees. Part C, I'll do some radians ones as well, so let's pick a radians one. I'm thinking 3 pi over 4. And then for part D, let's do pi over 6. So just a reminder for you, whenever you deal with this negative angles here, if our degrees is negative, then our radians is also going to have to be negative, because that negative really just tells us what direction we want to go in, whether it's counterclockwise or clockwise. If I didn't want to deal with a negative angle, I can always use coterminal to help us out by adding 360 to it. So let's go ahead and work with 270. So 270 degrees, and what I want to do here is multiply by a conversion factor so that I'm left with radians at the top and degrees at the bottom so that the degrees will cancel out. So remember my conversion factor, I'm going to use 180 degrees is equal to pi radians, and I'm going to abbreviate that as RAD. So I can use this as a fraction. So I'll do pi radians at the top and 180 degrees at the bottom. Now again, the reason I put degrees at the bottom is so that I could cancel out that unit of degrees and so that I'd be left with radians in the numerator. Now it's a matter of simplifying, so I'll simplify this by hand. The zeros would cancel out. 27 and 18 can both divide by the same number. They can both divide by 2. So if I reduce this, why did I say 2? I'm sorry. They both divide by 9. At the bottom, you'll be left with a 2. That's what I was getting caught up in. 27 divided by 9 would be 3, and then I'm still left with that pi. So we get 3 pi over 2 radians, which is what I said it was earlier, but now we just showed it a different way. Let's work with negative 210 degrees. So again, I'm going to multiply by pi radians over 180 degrees. And just to let you know, you could also use 2 pi over 360. It's just since we're having to simplify and stuff, it's nice to use smaller numbers. The degrees cancels, the zeros cancel. 21 and 18 are both divisible by the same number. 21 and 18 can both divide by 3. So I'd be left with negative 7 pi over 3. Oh, my goodness, my brain is so scattered today. 18 divided by 3 is 6. I meant to divide by 3, but then I wrote 3. I apologize for that. Sometimes I tend to make a little bit more mistakes when I'm not, in my comfort zone in front of a classroom. When I'm making these videos, I tend to make a little bit more like typo kind of stuff, So just bear with me. It'll happen, but my hope is that I always correct it very quickly. Okay, let's do these other ones. So these are going to go from radians to degrees. Now I know these are in radians because they have pi in them. I believe that your homework, the online homework, is going to show some that don't have pi, but they're like a decimal value. What happened there is that they just actually multiplied by pi, like they used a calculator, But the actual process would be the same. I usually try to structure this class to be mostly done with no calculator, so I try not to use those, unless we really need to, which sometimes we will later in the course. Okay, so starting with 3 pi over 4, and for this one, I'm still going to use the same conversion factor, but I'm going to multiply by the degrees at the top and the radians at the bottom. This is so that radians will cancel out. So technically this was in radians, so I can put radians here to keep that unit. So the radians cancel, pi cancels, and I'm left with 3 times 180 divided by 4. Now I'm going to do this by hand, so bear with me. Sometimes, I will make mistakes, so let's see. I have 3 times 180 degrees divided by 4. 180 can divide by the same number as 4, so they can both divide by 2. So let's see, that would be 3 times 90 divided by 2. Now 90 can then also divide by 2, so I can do 3 times 45. And again, this is degrees. And then 3 times 45 would be 90 plus 45, so that should be 135. So that's our answer. Now let's do pi over 6. So pi over 6 times 180 degrees divided by pi. And I can write radians. You don't really have to always write the word radians because we know that we're getting rid of that while we're doing our conversion. So the pi's will cancel out. 180 divided by 6 would be 30. So pi over 6 is 30 degrees. I really wanted to show you, I did pick these on purpose. As you will work through the course, there are certain angles that you'll need to know quickly how to convert from degrees to radians and vice versa. And I'm going to write those down for you, the ones that I would really like for you to remember and know how to get to very well, like very quickly. So 0 degrees is 0 radians. 90 degrees is pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2 radians. 360 degrees is 2 pi radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. And 60 degrees is pi over 3 radians. And so you could check all of these by using the conversion and everything, but these are the ones that will be really important for us to know. Now, if you want to learn the entire unit circle, and some of you may want to do that, maybe you have in the past, you would have to also remember that 3 pi over 4 is 135, and 210 is 7 pi over 6. And there's a bunch more that you would have to remember. I don't really teach trig from the perspective of memorizing the unit circle, so these are really the only ones that I will say I actually need you to know like very quickly and everything. All the other ones, I'll teach you other ways to figure out where they go. And we'll see that a little bit later. Or, well, maybe I'll just show you now, honestly. Let's just do it now. Yeah. So if I wanted to plot 3 pi over 4, I think this would just be a good time to practice it a little bit. If I wanted to plot that, and I didn't remember that it was 135, I would say, okay, I know this is 0, I know this is pi, or I can also write this as 4 pi over 4. And I can write this as 2 pi or 8 pi over 4. So then I would want to think, okay, is 3 pi over 4 closer to 4 pi over 4 or 8 pi over 4? Well, I would definitely say that it's closer to 4 pi over 4. So that means it's going to be on the left side of my graph. Well, is it lower than 4 pi over 4? So is it here? Or is it greater than 4 pi over 4? Is it here? It's less, so it's going to be right here. And then if you do know it in degrees, you can check that as well. Because in degrees, this would have been 180. This would have been 90. So yes, 135 should be right in the middle of those. If I want to plot something like, let's say, I'll do it down here because I don't want to run out of space. Let's say I'm just plotting radians. I'm just showing you how I do it personally. Let's try 7 pi over 6. If I wanted to plot this, I would also remember that this is 0 and this is pi, and it wraps around to 2 pi. But now, since I'm looking at a denominator of 6, I'm going to write pi and 2 pi also with denominators of 6. So this could be written as 6 pi over 6, and 2 pi, if I multiply by 6 over 6, can be written as 12 pi over 6. So then I decide, okay, is 7 pi over 6 closer to 6 pi over 6 or 12 pi over 6? And for this one, we'll see that it's closer to 6 pi over 6, but it is greater than, so it's going to go right here. It actually doesn't necessarily lie straight in the middle. It's a little bit closer over here, and we'll get better at that as we go along. And we can also check, because in degrees that was 210. So if this was 180, it makes sense that 210 is a little bit bigger than that. And then for one more, I'll show you like one with a denominator of 3. The ones that we're going to see in this course will have either a denominator of 3, denominator of 4, or denominator of 6. Or I guess technically denominator of 2. So let's do one like, let's do 5 pi over 3. So again, I know that this is 0, this is pi, this wraps around to 2 pi. This is 3 pi over 3. This would be 6 pi over 3. And again, I'm picking like what I want the denominators to be based on what this denominator is. And then I'm just using like fraction conversion by multiplying by 3 over 3. So I have to decide, is 5 pi over 3 going to be closer to 3 pi over 3 or 6 pi over 3? It's actually going to be closer to 6 pi over 3, and it is less than, so this is going to put it, I didn't mean to have the eraser on, this is going to put it in quadrant 4, is 5 pi over 3. Now the other ones, you're going to see that this is 4 pi over 3, and that this is 2 pi over 3. And if you memorize the unit circle, which we'll see later, you can remember where all of this goes, but this is just how I do it so that I don't have to memorize per se. Alright, I am going to move on a little bit now. So now we're going to move on to talking about coterminal. So example 2, I'll just say find one positive and one negative angle coterminal to, and we'll just do, let's do negative pi over 6. So for this one, I'm looking for one positive, one negative coterminal angles. So for my positive one, I'm going to want to add something to it. I do want you to remember that for our conversion, 360 degrees is the same as 2 pi if we're in radians. So regular coterminal angles, I just added, well, I say regular, in degrees, which we did last video. I just added 360 to the angle I was dealing with. Now we're just going to add 2 pi since we're in radians. So I have negative pi over 6, and I'm going to add 2 pi. And now I'm going to show you the work for this. When you want to add fractions together, you need their denominators to be the same. So I can multiply this by 6 over 6. Remember, every whole number is technically over 1. So this becomes 12 pi over 6. When you add fractions, you add the numerator and you leave the denominator the same. So this would be 11 pi over 6. And again, the reason that this is helpful to us is that now instead of plotting negative pi over 6, I would be able to plot 11 pi over 6, and I won't have to have a negative angle. Now just for practice, we'll go ahead and do a negative coterminal angle as well. So for that, we're going to subtract 2 pi. Again, I need the 2 pi to also have a denominator of 6, so that would be 12 pi over 6. I get negative 13 pi over 6. So here are my two coterminal angles. Alrighty, moving on. I'm going to move on to talking about arc length now. So this is technically arc length of a circle. So I'm going to give you a definition. The length S of an arc intercepted by a central angle of alpha radians on a circle of radius r is, and I'll give you this formula. Formula is S is equal to alpha times r. I'm also going to draw you a picture to show you like what this is talking about. So if I have a circle and I have this angle, and I know how big that angle is because I know alpha, this is S over on the edge here. This length, let me use a different color actually. This length here is what we are calling S. But it depends on how big my radius is. Really what I want you to think about for this problem is the definition of radians. So the definition of radians is also the length of the arc that is intercepted. The only difference is when we just talk about radian measure in general, we use the unit circle. So our radius was set as 1. Now we don't know what our radius is, so we have to just call it r. And we'll be told throughout the problem, like what the radius is, but for the, formula. So I want to remind you that circumference is 2 pi over r. So if I was looking at like the whole circle, that would be 2 pi over r. But I don't want to look at the whole circle. I just want a portion of the circle. So instead of using 2 pi, I am so sorry, that definitely just showed up on the video, and I'm not really good at editing, so I don't really know if I'm going to be able to edit that out. It also crashed my thing. That's cool. Oh, sorry about that for those of you who are watching. So let me get back to what I was saying. We're just going to replace the 2 pi with alpha. And there we go. There's our equation. So instead of looking for whole circumference, the whole 2 pi, we just want to look at maybe a portion of that. So that's why we just use our angle instead to find the length that we want. So let's go ahead and do an example. So this will be example 3. And I am going to have a few of these to do, so we'll go ahead and just say finding arc length. And I'm going to break this up into parts. So the first one that I'm going to give us is, yeah, this is a good one. A central angle of pi over 2 intercepts an arc on the surface of Earth that runs from the equator to the North Pole. It says use 3,950 miles as radius of Earth. Find the length of the intercepted arc. So of course I would recommend like pausing to write this down, but I'm going to go ahead and read it again. A central angle of pi over 2 intercepts an arc on the surface of Earth that runs from the equator to the North Pole. It gives us the radius of Earth, because I would not expect you guys to just know that. And we want to find the length of this intercepted arc. So I always like to draw a picture of what I'm dealing with. So we're talking about Earth, so I'm going to draw a circle. I know that the radius of Earth is 3,950, only because they told me. Also, let's make a point here. It says from the equator. So the equator of Earth is this horizontal line that cuts through the center of Earth to the North Pole. Well, the North Pole is located, we're going upwards. And then also my central angle is pi over 2. Well, this makes sense that my central angle is pi over 2, because if I'm thinking of this as like a coordinate plane, 90 degrees is pi over 2 if I look up like that. So we're looking for this length S on the outside. So I'm going to take my angle and multiply it by my radians. So I get pi over 2 times 3,950. And I'm going to go ahead and get that value. This would be 1975 pi. Now, I don't usually like to simplify so far to get rid of the pi, but the your homework may ask you to do that. Also, this is in miles since the radius was also in miles. If it asks you to just pay attention to on the homework, it's going to be like underneath the text box. It'll say either leave your answer in terms of pi, or it'll say something like round to the nearest tenth or something. If it's talking about rounding, it probably wants you to actually multiply by pi. If you did that, you would get 6,204.65 miles if we round to 2 decimal places. Now, I'm a bit partial to, I like just leaving with pi, just because, I don't know, I just do. And because I usually like to give you smaller numbers so that you don't actually need a calculator for these calculations. So let's go ahead and do one more of these. Very similar. It says a wagon wheel, or the wagon wheel, has a diameter of 28 inches and a central angle of 30 degrees. What is the length of arc S? Sorry, I don't know if you heard me. I just kind of yawned a little bit, and I'm pretty tired. So again, I'm going to draw a little bit of a picture. We do have to be careful because it gives us the diameter, but for our calculation of length S, we only want the radius. Also, it gave us our angle in degrees, so we don't have alpha then, because I need it to be in radians. So a few things. My radius is the diameter divided by 2. So to get my radius, I'm going to do 28 divided by 2, which gives me 14. Also, it does say 30 degrees, which, I don't know, I'll draw like here, but I'm looking for this length S. Now to find alpha, we could just use the conversion if we need to, but it's one of the ones I told you should be pretty familiar with, so I'll just write that 30 degrees is pi over 6. So I had to convert that. Now I'm going to plug everything into my formula, so I get pi over 6 times 14. And again, I like to just leave it as fractions, so this would give us 7 pi over 3. If we leave it with pi, this is in inches. If you want to simplify, let's see, it would be 7 pi over 3. It'd be 7.33 inches. One more before we move on to area. This one is a little long. So it says the distance between LA and New York City is 4,505 miles. Find the central angle to the nearest tenth So this one, it's telling us that it does want us to round of a degree. That's also important. We want it in degrees. That intercepts an arc of 4,505 miles on the surface of Earth. And I'm also going to give you again radius of the Earth is 3,950 miles. So this one's a little bit different. This one's giving us different information. So I'm still going to draw my problem. I like to just kind of draw them the same way. So I know that my radius is 3,950. It says the length of my arc. So I do not know alpha. I don't know it. I know that the length of my arc, so that's S, is 4,505. And so I'm looking for alpha, and then I'm going to have to convert to degrees, because it doesn't want alpha as like radians, it wants it in degrees, so I am going to have to convert that. So I start with my formula. Arc length is equal to alpha times r. I'm going to plug in what I have. So I have 4,505 is equal to alpha times 3,950. To solve this for alpha, I can divide by 3,950. So I get 1.1405 is equal to alpha. But this is in radians. So now I have to convert. So to convert this to degrees, I'm going to use my conversion factor. So I have 1.1405. If I want degrees, I'm going to multiply by 180 degrees over pi, and that's in radians. So the radians will go away now. And I'm going to have to use a calculator for this. I mean, there's no way I can, do this by hand. So I'm going to go ahead and do that real quick. So times 180 divided by pi. And I did not round until my final answer, but I get 65.3 degrees. Now that's going to be it for our arc length So we'll go ahead and move on now to area of a sector. So for this one, just like with the other, I'm just going to write you the kind of definition first. So area of a sector with a central angle alpha in radians in a circle with radius r is, and for this one we're going to do capital A is equal to alpha times r squared divided by 2. So this one, what we're dealing with here is that we have a circle, We're still going to want our radius. We're still going to need to know how big, like, of a area we have. So that's why we need alpha. But we're looking for this area inside. So we're going to have R. We're going to have alpha. That kind of doesn't look good. I'll write it like this. And we're looking for everything inside, including the alpha, but try not to cover it up. Now I do want to show you a little bit like where this formula actually comes from. So if we look at just area of a circle, area of a circle is pi r squared. So, and remember that that's the entire circle. So if I'm thinking about like what my angle would be in this situation, my angle alpha is actually 2 pi. But if we see how it says pi, it's because we've divided by 2. So if I take this and divide by 2 on both sides, I get that in this area formula, pi is equal to alpha over 2. And so that's where this is coming from. I'm replacing pi with alpha over 2 for the new area. Since I don't want just area of the whole circle, right? I want area of just a little piece. So that's kind of the idea of where it comes from. And I'll just go ahead and do an example. So we won't do too many for this one. I'll just do the one. So it says a center pivot irrigation system is used to water a circular field with radius 200 feet. What area is watered if the central angle is pi over 8? I really do like this question because I could really see this happening, if we think about like a farm and we say that it's a circular farm, and basically what it's saying is that we have this irrigation system in the middle, and we need to know if we're only looking at pi over 8, so that's actually pretty small. If we're only looking at this much, what area of this farm is actually going to get watered or field? And I could really see this working for like a farm or something, and being able to expand on this question and saying, well, I have, the plants in this area need to be watered 2 times a day, but then the plants in this area of the field need to be watered 3 times a day. So there's going to be some time where this overlaps. I don't know. That's just kind of the idea that I could see this problem expanding to, and really being able to use that trig to help. So let's go ahead and do our problem. So we're looking for the area. So we have area is equal to alpha over 2 times r squared, or you could just leave it all over 2, that's fine. And I will go ahead and plug in my values. So I know that alpha is pi over 8. I know that my radius is 200, and that's squared, and then I have to divide the whole thing by 2. Excuse me. So if I want to simplify this, let's see. Pi over 8 and then this is 200 squared. Now I don't want to accidentally multiply it by the 8, so I'm going to remember that everything's over 1. And so 200 squared would be 2 squared is 4, and then I would repeat the zeros. So I'd have 4 zeros for this one. It would be 40,000, and then this is divided by 2. Remember that when you divide by 2, that's the same as multiplying by 1/2. So I don't really like seeing this as such a complex fraction. So I would write pi over 8 times 40,000, and then that's over 1, times 1/2. And now I'm going to go ahead and simplify this. So I'm doing all this by hand, so I really don't like to make my numbers bigger if I can help it. So I'm not going to multiply the 8 and the 2. I do see that 40 can divide by 8, and that would be 5. So that would leave me with 5,000 pi, and now the 8's gone, so I just have it's over 2. And then 5,000 divided by 2 would be 2,500 pi. And this would be in feet squared, technically. I'm not really a big stickler on like the units, to be honest with you, but that is what it would be. Didn't mean to have my eraser on. So let me go ahead and box that in. If you did want to simplify this answer fully, so like multiply by pi, it'd be 7,853.98. Like if we wanted to multiply out the pi. And we could do this this area equation with any of the above examples. So any of these, I could say find the area of the sector that we created or something like that. Really the main things to remember with these is that you've got to convert to radians. If you're not, make sure you actually have the radius and that you plug into the right equation. So that's going to be it for us today. I hope that, well, for this video, but I hope that y'all have a wonderful day, and I will see you in the next video. Thank you. Bye-bye.